you so much. That's really great. Thank you for having me here. That's really great to stay here again. And before my presentation, let's start with. I like to start with stories, and let's start with a real stories. Basically, a few months ago, I was leading a security assessment for a manufacturing company. Nothing usual at first. Web application, internal network. They use the scope, but the moment I started probing deeper, I realized the application I was testing was only from the door. Behind it sat an Azure SQL instance, a storage account with years of operational documents, a Entra ID service with principal more and privileged than anyone remembered, the greeting, and all the credentials to reach those cloud services were sitting inside a compiled DLL on an Ubuntu services nobody had patched in 18 months. The assessment took there basically 3 days. The finds were not about one vulnerability, they were about a path. So from on-premises code to cloud data to identity abuse, and that moment changed how I think about penetration testing. So let's start with my presentation. My name is Milton. I am a security researcher and council instructor. I host the Ornating.io podcast, and my work today involves entirely around one question, that is, where does your on-premises infrastructure stop and where does your cloud risk actually begin? Because attackers already know the answer. Our job is to first find theirs. So I'm as well. I worked with XDR evasion and a lot of another things, but today I will talk only about penetration testing across the hybrid environments. So let's start with some of my certifications. I hold several industry certifications. They are on the screen behind me, and I want to tell you something honest about every single one of them. No certification exam I have ever taken asked me to pivot from on-premise Docker containers to Azure SQL database using credentials extracted from a .NET assembly. No exam asked me to chain unauthenticated API leakage, reverse engineering, cloud data plane access, and identity abuse into a single attack narrative. So no multiple choice questions ever prepared for me for the moment, and a client just asked. So you read our production database from a Kali virtual machine in coffee shop right now. So certifications gave me structure, vocabulary, a baseline, but the skill that actually matters in hybrid penetration testing is the ability to look at a system that spans on premises and cloud and see the invisibility threats, of course, and the trust relationship, the red coded strings, the firewall that should not exist, the service principle that was supposed to be temporary 2 years ago. And if you are early in your career, pursue certifications. Of course, they will open they open the first doors, but after those doors open, do stay in the textbook. Build labs, that's power environments, break your own applications, follow secrets wherever they lead, because the attackers that matters in 2026 do not fit on the multiple choice exams. They fit on Kali terminal, maybe an Azure subscription and path nobody tested before you. So let's go to our agenda. Here it is, basically our roadmap for today. First, why hybrid infrastructure changing basically the meaning of penetration testing, how the attack surfaces that matter when cloud, on-premise identities, APIs and containers are connected. Third, a live labs with my Vuni app, that's called R19, and on-premises ASP.NET application talking to Azure, SQL, Blob Storage, Key Vault, and the Enter-ID. For a complete, I will show you the complete attack chain from the CAD machine to Ubuntu to stolen secrets to leave cloud data impact. Fifth, how we translate findings into business risks, remediations, and continuous validations. And through these sessions, keep one question in mind that I said in my last presentation as well. If were the attacker, what you do in the next, because that is exactly how modern adversaries thinking nowadays. So let's open with the modern attacks. So modern attacks hardly target a single environment. So that sentence, it's not a slogan, it's how adversaries operate every single day. So threat actors move across cloud platforms, enterprise networks, identities, APIs, containers maybe, Kubernetes, and internet-facing applications. They do not stop at perimeter. They exploit the trust relationship that connect hybrid infrastructures and on-premise infrastructure. So on-premise infrastructure talk with cloud database that I will show you today. Containers authenticate to identity providers, APIs, carry secrets between environments that were never designed as one security domain. If your penetration testing only looks at one of those pieces, I'm sorry, you are not testing the real attack surface. You are testing a fragment. And attackers do not attack fragments, they attack paths. So let's go right now to the hybrid. So let's, look at the typical enterprise today. So some of workloads still run in a data center or on maybe a local Ubuntu host. Some sit in Azure, GCP, or maybe OCI Cloud. Identity may live in Active Directory, Enter-ID, or maybe both sometimes. It depends on your environment. It depends of a lot of things. And business data may live in SQL, Blob SaaS, or three add-ons. The application your users open in a browser, maybe it's local. So, but the truth of that application sometimes is nowadays it's hybrid. The inventory list comes from Azure SQL, The documents come from blob storage. I'm talking about, Azure. In this case, I'm using only the Azure environment, but you can replicate this for AWS to using S3 and stuff like that. And the identity service comes from Entry, and the security was supposed to come from Key Vault. Key Vault is from Azure, from Microsoft Azure as well. And this is not future architecture. This is the current architecture, and what is why hybrid penetration test is no longer optimal. And then this is my question for all here. So, and why traditional penetration testers fall short? Basically, traditional assessments often slice the word too clearly. Let's say one team tests the web apps, another team reviews cloud posture, another looks at Active Directory, another writes a container and scan report. Sometimes each report can be correct, and the organization can still be wrong about the risk, because attackers do not basically respect those work packages or do not respect this flow. The attackers find the on-premise application, sometimes steals the cloud connection strings, read production data in Azure, exfiltrate documents from storage, then try the services principal for with their pivot to another environment. And right now with multi-cloud, we have a lot of ways to do that. I'm sorry. So that's not necessarily shell on the control plane required. That's totally different today. No zero day required today. This is just a path. So modern offensive security, it's about validating whether that path exists end to end. We needed to put this in our mind. That's really important. So and then when you say hybrid attack surface, we mean at least 5 connected layers. The first one is on-premises, hosts, and applications. After that, we have APIs and diagnostic endpoints that expose operational truth. After that, we have identities that you can call users, service principals, managed identities, app registrations, and we have cloud data plans like SQL storages, Q vaults. 5, the trust fabric between them firewalls, connection strings, token secrets, and network paths. And most organizations inventory assets. In few organizations, let's say inventory trust. So hybrid penetration testing starts with the trust. So we needed to understand that, so that we can understand the next step of this presentation. So what hybrid penetration testing actually means? Hybrid penetration testing is not do a web test and then a cloud test. It's one of engagement model with one, let's say, one narrative. Can an adversary move from the environment? We can reach to the environments that hold business impact. That means we test authentication, authorization across boundaries, security handling in code and runtime, API exposure, identity privileges, data plan access, and maybe detection gaps along the path. The deliverable is not only a list of CVAs. The deliverable is basically demonstrated an attack story with business consequences. And I will talk about business consequences after in the next few slides. So let's introducing my Vuln lab here. To make this concrete, we basically built a deliverable lab that's called Vuln App R19. Basically, this is an ASP.NET Core 8 inventory application. That's a simple application that I used ChatGPT to create this application. That's really fast, because I'm trying to show you something that really can happen in your business right now, or maybe are happen in this time. So it's look like a normal internal business app, and basically product catalog, stock, documents, and behind the UI, it's hybrid by design. So the apps runs on Ubuntu on premises. The inventory data lives in Azure SQL. Documents live in Azure Blob Storage. Configurations, reference keys, and entry the app in app registrations. I mean, this is not a CTF gimmick. This is with a single flag. It is a compressed model of how many real systems are built under delivery pressure. It's like ship the future, connect the cloud services, hard-coded for security for now, expose a diagnostic API for support, and move on. How I can say all the time, attackers love for now. And then, okay, let's go to the lab architecture. So in the left side, we have the attacker workstation. I use the Kali Linux machine. In the middle, we have the Ubuntu running Docker containing with my app, Vuln App R19, on the port 5000. And in the right side, we have the Azure with Azure SQL database, with a database that's called catalog database. We have the storage account inventory to inventory documents. We have Key Vault. We have entry ID tenants and service principal. And the critical arrays are not only TCP to web UI. The critical arrays are app to SQL, app to blob, app to identity. And if we succeed attackers to those same cloud services using stolen application trust, remember the talk line. We never need a shell on Azure to hurt Azure data. We need to basically the secrets the applications already holds. It's enough to create a, let's say, a nightmare for businesses. So okay, yeah, the slides it's not running. Okay, so the methodology before my demo, before we touch on keyboard, basically we need to talk about Reconnaissance. What is reachable? What does it admit about itself? And we have a surface mapping, UI, APIs, binary containers, secret recoveries from APIs, reverse engineering, image layers, and we have here the cloud pivot, authenticate as the app, not as a guest admin. We have impact, where you can see confidentiality, integrity, and optional availability within roles of engagement, and the translate business risk and remediation that actually break the path. And we have as well retest, because hybrid environments change every week, and tools can help us. Methodology, as I say, decides all. So, and let's go to the live demo. So we basically I will demonstrate right now how this works. We have basically the target that will be a Ubuntu with a port on 5000, an attacker machine with running Kali Linux. We have the cloud side with real Azure SQL and plugging to the lab subscription. If something fails, that is also I'm teaching moment. Hybrid attacks, let's say, depends on firewalls, identity permissions, and network paths. Real environments fail in real ways. So what I want to watch is not a total case. It is, I want to watch this the moment the bridge stop being local and become the cloud impact. So let us begin. Let's stop my screen here to go to my virtual machine. Usually people like when I start with virtual environments here. Let me just try to find my virtual machine here. I think that's work. I think that's all people can see here. So this is my Kali Linux machine. Just let me see. Yeah, I think it's a little bit. Oh, okay. Oh, that's not okay. My virtual machine. Let's see what's happened. Okay, just to show my IP address. My IP address is it's finished with 224, and my application run with 98 with the port 5000. So that's a simple application that I created using artificial intelligence, to be clear and to be honest with you. So we have here, as you can see, these applications are connected with Azure, and basically that's a simple application with where we can basically fill something. So let's just test here. So let's update here, and if you can and if you can see, okay, this was okay, dashboard, yeah, test Cisco Catalyst. So if I go to inventory system, let's run one query here, and you can see basically the test that we update early. So, and then this application, we have a lot of problems here. Of course, we have this application work with APIs to update this not only to update but to read informations here, and then from my virtual machine we will start basically exploiting these vulnerabilities, these APIs, to get informations about secret keys and stuff like that to go to cloud environment. So to be more easily, it should be more, and to be more fast, okay, I already created basically a script that you execute all steps, including Reconnaissance and another steps to exfil informations, to update informations in a cloud database and stuff like that. So I will execute my script. If you look inside of this script, basically we have here a lot of attacks. So we have a lot of attacks and string connections to connect with database and whatever. So, and after that I put this available on my GitHub so that people can use to another presentations or to try to exploit in the same way. So let's start. You start the attack. Look, we just have here, okay, we already have the down. Let me just update here, penned by Kali. This was in my test because we need to test before the presentations, of course. So okay, let's start. So my script basically will execute all steps, and I will explain all the steps, all phases, so that you can understand how this works. So here it's my script. This is my script, and this is my victim IP address. And let's start. And the first one, it's the phase one that you start with Reconnaissance in on-premise infrastructure. So executing any map. Okay, the attack, it's already completed, but let me explain you. And in the first time, basically we recognized the port 5000, and we detect as well 4 API endpoint that was basically an unauthenticated API surface with 4 APIs. And after that, we identified the credential theft via exported APIs, and we don't need it to out in this case. And in the same time, we basically we dumping basically all informations about secret passwords, database, ports, and all that I need to go to the cloud. After this presentation, of course, this doesn't work anymore, but okay, let's start. And stolen credentials, okay, so with secrets, with storage, and with basically the storage SQL. And in the phase 3, we connected in this virtual machine, assuming that we have access on and via SSH on this machine, and we get the DLL file that's called vulnapp or19, and we basically used one expression to try to find information about database, about information about the password, account key, and whatever. So here in the phase 4, we basically using these informations, we pivot to Azure SQL and read and temper and check the integrity. And then in this case, we already inside of our Azure environment. And here we complete an update. So we basically insert rows there. And here we pivot as well to Azure blob where we can extrude documents. Basically, you can see here, I'm not show you, but basically we have a lot of documents, okay, inside this platform. Let me show you. Okay, it's just a confidential document. Let's imagine that was I don't know, PDF files with sensitive information maybe. And basically we don't need to parse the token, and basically we have here the impact summary. So, and if you go back to our application, we can see already the information that was owned by Milton. That's my name, of course, and attack controlled. And basically with these informations, I could not only attack my local infrastructure, but update informations inside of my database catalog. So let's try to find it. Remember that was my last query, and right now I run this again, and look that right now we have another ID that's 21 owned by Milton. Information about, okay, I put inside my script and stuff like that. So in this case, I showed the full attack path to exploit an applications and to pivot to the cloud environment. So let's go back to our presentation. That's what really short. So I just created, and then I created with a script to demonstrate more easily. So let's share again. You probably can see this again. So let's start with, right now I will explain what this really happened. And in the phase 1 we have the reconnaissance. We start where many internal or assumed breach assessment start a reachable roast, and open service support in this case was the port 5000. It's open, and the service fingerprint points to an HTTP application in ASP.NET Core. So, and we have here headers and the response that confirm a web app in production mode. And we have as well the health endpoint with no authentications, and it tells us the app name that's called VoneApp or 19. The framework that, one more time, ASP.NET Core 8, and a critical flag that is Azure connected through. And so already the on-premise host is advertising a cloud relationship. So we have the version, build date, runtime, operational system. This is the fingerprint code for an attacker choosing exploit and reverse engineering strategy. And so the taking basically the point for the audience is unauthenticated operational endpoints are not helpful monitoring. They are attacker recon or reconnaissance APIs. So this was just the first phase. So right now we have the phase 2, and basically that was API abuse. So in modern hybrid apps often expose diagnostic for support teams. In security designs, those diagnostics include cloud configurations, look at what we receive without to login, hostname, OS, process paths, perhaps, and Azure config with tenant ID, client ID, SQL server name, database name, storage account, key vault UI, subscription ID, resource group, we have just mapped the cloud side from the on-premise side. Now, the dangerous one, that is the full string connections with SQL user and password, storage account key. This is not a vulnerability scanner find about in missing security header. This is direct credential disclosure. In under a minute, the attackers has moved from I see a web app to I can speak to Azure as the app. And pause here. This is the hybrid environment. The breach is still on premise, but the impact is already cloud shaped. So, 1 minute, please. Water, it's live, please. Drink water. So let's go to the phase 3, that is basically the reverse engineering, where we can imagine that we have access on directly inside of the server, and basically this is like a alternate and complementary path. Suppose the API endpoints were locked down tomorrow. Would the risk peak disappear? Not if secrets are compiled into the binary. Constant strings in .NET become literally in assembly. Cloud config is reverse engineering friendly by design. I mean, unfortunately, this is unfortunately for defenders, because public constant strings for tenant ID, client secrets, SQL, passwords, storage keys, even a comment saying secrets should come from key vault while the code does the opposite. And talking point, security architecture is not a commenting source. Security architecture is what ship is built artifact. So in hybrid environments, always ask where do runtime secrets actually lives. So you can ask environment, managed identity, key vault with short-lived access, or DLL, the image layer, and the support API. So this is our main question here. So and basically the fourth phase, we have the cloud data plan, that's the same Azure SQL, where you use basically the stolen SQL credentials from on-premise application with, for example, server, SQL, catalog, database, whatever, .windows.net. Database, that was called catalog database. User inventory, that was called inventory app service. And if you can see here, not Azure portal access was required. No subscription on it role required, just network path to the port 1433 and validate database credentials. And the confidentiality impact is full inventory disclosure, prices, stocks, locations, business data. Now is integrity. The on-premise UI show the cloud true. So you probably remember that you had the badge, data source Azure SQL, and you can see Dell server price manipulated, attacker role visible to business users, and the key sentence for the talk it is: we did not need to a shell to Azure. we did not answer the Ubuntu roast. We compromised the truth path between the local software and cloud data. And yeah, that's it. So let's go to basically the exfiltration step, basically the phase 5, in place with the cloud object storage and with storage account key from the same secret leak. And the documents appear manifest files, notes, operational files, and the exfiltration was complete. And the talk point is the database compromise, host extractor, business records, storage compromise, hurt files, export backups, and temporary confidential documents that people forget about. This happen all the time, trust me. And I see this all the time during security assessments every single day. So in hybrid incidents, attackers often take both SQL for system of record, blob for bulk exfil, and yeah, whatever. So and basically the phase 6 was the identity, where you can see the client ID and the client secret from the application, our client credentials against intra-ID token endpoint, where are no longer only a SQL user. We are on application identity. Depending on grant, this can mean graph access, key vault access, or broader Azure control plane access. So in this lab, full subscription takeover may be limited by design, and I'm here, and this is the honest. So real assessments must show both. So what worked and what was blocked by least privilege. And we talked the point. Successful hybrid pen testers measure blast radius, not only initial access. Sometimes the most valuable find is the secret works for data plan X, but the identity B cannot touch Z, for example. The guides remediation investment. That's really important. I mean, that's really important, so that to explain and you can explain the real story. You cannot show only what happened or what was successful. You need to show for your customer or for your maybe inside of our business what failed as well. So here, so let's go to the brief of let's recap. So let us recap the path in one, let's say one brief, and basically our Kali machine finds an on-premise web applications, unauthenticated APIs, disclosure, Azure configuration and connection strings. Reverse engineering confirms that the same secret inside of vuln app or 19.dll. Stolen SQL credentials yield read and write on Azure SQL. Stolen storage key yield document exfiltration. Service principal materials enable identity plane attempts against entry-ID. So we start in local infrastructure and we went in a cloud data and identity impact. This is penetration testing across hybrid infrastructure, not as a slogan, but it's basically a chain. So let's go to the next one. That is by executives. Executives do not buy CVA's counts. They buy clarity on business outcomes. And right now you need to translate this demo for a CEO maybe, or for CFO maybe. And basically, let's try to explain the finding. The finding is secrets embedded in application and exposed by APIs and the RCO. What the fuck is that? So business risks: unauthorized access to productions like inventory, data, and documents, integrity, abuse of business records, potential maybe identity abuse. And you need to explain the likelihood. Okay, the likelihood is high in organizations with HAP delivery and weak secret hygiene. So the priority that is critical for any system with cloud data access. And we have the impact categories. It's like confidentiality, that is data read and file exfil. Integrity, because they can see price and inventory manipulation. And the availability, because it's optional, because the attacker can be destructive in actions if the privilege allow. You have as well the compliance, because we have evidence of uncontrolled production secrets. This is how offensive security work becomes decision support for the high level. So let's go, and let's go basically to the remediation. So must close path, not the correct report. The first one, we need to fix this. We need to remove the authenticated API config and API diagnostic exposure if diagnostics are required. So we need to protect them and redact the secrets. 2, we need to eliminate hard-coded secrets inside of source and compiled assemblies, and prefer managed identity for Azure SQL and storage where it's possible. The 3, use key vault reference and short-lived credentials when secrets are unavoidable, and never constrain client secrets. 4, SQL file and least privileged database roles. That's really important. And application accounts should be not wider than queries they need. 5, avoid long-lived account keys in apps, prefer airbag and narrow SaaS. That's really important as well. 6, container hygiene. No secret imaging layers. It can build artifacts, restrict how can pull production images. 7, continuous test the chain after fixed strings on the new DLL, outside tests on APIs, confirm old credentials are revoked, and then that's really important. A fix is not a ticket state. A fix is a broken attack path. So and let's go to basically expand, and let's try to expanding beyond this lab. So Vun app R19 is one story. Your enterprise has many stories. The same methodology applies to Active Directory, intra-ID, hybrid environments, Kubernetes, APIs. So internet-facing applications, that means tokens for private services, containers that mount credentials for multi-cloud environments or multi-cloud automations. When you're playing a hybrid penetration test scope, needed to trust in relationships split. Not only IP ranges, not only web, app, OWASP top 10. You need to focus on scope the identities, the secrets, the data stores, and the admin planes those apps can touch. So, and AI is part of offensive security and defensive workflows. It can accelerate recon parsing, code review, payload drafting, and report writing. And in a hybrid assessment, AI can help correlate API output, binary strings, and cloud privilege much faster, but AI does not replace attacker judgment. So it does not automatically know which path matters to the business. It's not feel when a low fine is actually the ring between on-premise and cloud. You need to use AI to move faster. Use human expertise to choose the directions and validate the impact. And I mean, the winning programs will combine both under strongholds of engagement and operational safety. So let's go. I'm already finished. And hybrid infrastructure changed for let's say annual only true. The continuous validation means retesting critical attack paths when apps deploy, when identity change, when network roles change, when new cloud services are connected to old systems. For a path like today's demo, continuous control might be include secret scanning CI or CI/CD, authenticate API regression tests that fail if configurations leaks return, periodic validations that production binaries contain no credentials, literally, cloud posture checks on SQL file and exposure, identity reviews for applications, registrations, and unusual secrets. Penetration testing becomes a program input, not once a year PDF report. So let's talk about basically, and when basically talk testing hybrid system, and we need to understand that this is required discipline. Agree on scope across on-premise and cloud subscriptions. Define which data stores may be read, writing, or only provide non-destructive canaries. Coordinate change window when tempering business data in scope, as we did with inventory prices. Prefer evidence that proves impact without necessary destruction. Log attacker actions for blue team learning when the engagement include that action's objectives. And the point of offensive security is strong resilience. It's not a surprise outstage. Let's go to some takeaways here. And we have here 4 takeaways. The first one is hybrid attacks follow trust, not org charts. So test the connections. Second one, APIs and compiled applications are first-class credential source, and treat them like production secret stores under review. Third, cloud impacts does not always require cloud perimeter breach. That's really important so that you can understand this. Sometimes on-premise software hands you the keys. 4, measure success by business impact, attacks path, and verified remediations, not by to output volume. So, and basically, you need to understand that modern cyber attacks rarely target a single environment. Neither should modern penetration tests. If you assessment stop at server, the website, or the cloud console in isolation, I'm sorry, but you will miss the story attackers actually write. So across the world platforms, enterprise networks, identity, APIs, containers, and applications through the trust relationships that make hybrid business possible. Identify those paths before they are weaponized, and that is not optimal anymore. It's the core of the strategy. And so that's it. Thank you all. The Microsoft Azure, not only Microsoft Azure, but another cloud environments or cloud providers has a lot of, for example, in Microsoft Azure, you can use, for example, the Microsoft Sentinel, that it's basically CN, that work as CN, and then you can, for example, identify this kind of behaviors using or correlating logs using the Sentinel. That's a great platform from the Microsoft Azure. That you needed to the concern need to be with both. This depends on, of course, this depends on your environment, but you need to, for example, if you have an application that are exposed to the internet, you need to focus on, of course, in identities, and because right now in a dark web, in deep web, whatever, you can see a lot of leaks, and sometimes the attack not start with one and a vulnerability, but starts sometimes with a credentials that was leaked, and then sometimes if your application is exposed to the internet, that's great to start with identities. But if your application is not exposed for the internet, I think that's great. You conduct your common penetration test internally, but depends on your environment, let's say. So you needed to the inventory. Okay, when you talk about security inventory, we need to talk, for example, the concept that's called business impact analysis, and then we need to basically collect the inventory of all that is critical for our environment or infrastructure needed to run correctly. So the best practice is inventory all. So you need to inventory services, you need to inventory apps, you need to inventory securities, you need to inventory a lot of things, because you need to know what you have inside of infrastructure, so that you need to know what you need to protect. And then that you have the inventory, it's the best price for all. It depends on independent of if you have only on-premise infrastructure, or if you have the cloud infrastructure, or if you have the hybrid infrastructure. Okay, for sure. For example, APIs and applications, you have, for example, the WASP Top 10, but you have WASP Top 10 not only for web applications, but to have WASP Top 10 for mobile applications. APIs right now you have for AI, you have sys controls, you have a lot of frameworks, for example, not only for internal environments, but for cloud environments. For example, in Microsoft right now, you have the Microsoft Purview, that you have a lot of recommendations that you can follow to grow your score there. And then you have a lot of tools that when you basically join in Microsoft 365, you have a lot of free tools that it's not free because you need to pay before, of course, but you have a lot of free tools that you can use inside of our tenant to create hardenings that you'll be capable to create a resilience inside of your infrastructure. Sometimes you don't need to have a specific framework to protect your assets inside of, for example, your Microsoft environments. You have a lot of controls that they already built, so that you just follow, and you sometimes just need to some clicks to complete tasks, and you can grow your score there. Yeah, on my job, of course, I cannot expose, but you have a lot of, for example, supply chain attacks. For example, some years ago, you had, for example, one supply chain attack that started in basically that was and as a target the SolarWinds. That basically started from another partner that had connections between businesses, and basically the attack started on in this partner that using the supply chain attack, let's say, that was possible to basically to create to purify this attack to the SolarWinds, and of course to the cloud of SolarWinds and local infrastructure of SolarWinds, and then this was a big nightmare. But we have a lot of examples. You can go to the Google right now and to try to find out the incident, the supply chain incident from SolarWinds, and you can see the big incident that happened. I don't remember. I don't know if it was 1 year or 2 years ago. Right now, I cannot remember. But you can see a lot of supply chain attacks that basically start usually in a local infrastructure, maybe sometimes with a phishing mail, and go to cloud environments. Thank you again. I really appreciate your time, and thank you for having me. That's ever great to. That's really great to have stay here. So thank you again. Keep learning. Stay curious. And if you want to connect with me on my LinkedIn page, that's easy to find me there. It's Milton Araújo, and you can find Milton Araújo, security researcher. That's really easy to find me. And that's it. Connect with me, and if you have questions, I try to answer all the questions there, and I try to help people there from my not only from my podcast, but and follow my podcast as well, r19.io, Hackers Behind the Code. That's it, and I really appreciate your time again.